Hello everyone, welcome back to the solutions for the NSAA 2017 paper. We're at question 17. Question 17 is part of mensuration, and mensuration is a part of geometry in ESAT syllabus. So if you do not find mensuration questions, look into the geometry chapter, you will find them. Now this is a question on volumes. It says that you have a cylindrical pipe. So you know how cylindrical pipes are, right? Uh, They will have a thickness that it will be made of the metal or the PVC that is required to construct the pipe, and there will be space for water to flow. So there will be an external radius and an internal radius. In this problem they have given diameters. Okay, so be very careful. If you use the diameters you will get a wrong answer, and definitely that wrong answer will be one of the options. Okay, so external radius, half of the diameter, right? So external radius r is 5 centimeter and internal radius small r is 8 by 2 4 centimeter. So what will be the volume? Volume is pi r square h minus pi r square h, right? So I can just take common, and pi r square minus r square into h. Now I know the value of r and h, right? So should not be very difficult to continue from here. So it is pi into 5 square minus 4 square into 16. So 25 minus 16, 9 into 16, 144. So 144 pi. Now density is given 8, 8 grams per centimeter cube, right? So mass equal to volume into density. So 144 pi into 8. You can do this multiplication directly, but I'll show you one more technique. See, 8 into 4 is 32, right? So the last digit should be 2. Whatever answer we have, the last digit should be 2. Others are not the answer. So this is not the answer, this is not the answer. 72 cannot be the answer because, well, it's way too small. Not the answer, not the answer. 512. I am multiplying something that is greater than 100 by 8. The answer should at least be 800, not the answer. 1152 fits the bill, is the answer. Okay. Now I showed you this technique by eliminating all the options, so it took a bit of time, but I have been doing this for quite a long time, so this is second nature to me now. I'll just check 8 into 4, 32. Alright, last digit 2, something should be greater than 800, only one option, option G, done. Okay, this multiplication is easy. Even without this technique you could have done it quite easily, right? 8 4s are 32, 8 14s are 1112, add 3 to it, 115, 1152 pi is the answer. Alright, but I just showed you this technique because keep it in your arsenal, keep it in your head, and wherever you feel like you can eliminate some options, use these. Alright, so you can use quite a few of these techniques that I have told you over the last few videos, and make sure that you practice them when you are looking into exercises and stuff. Alright, you may be required to write the full answer, but why not test yourself? Because if you do not test them, you will not be able to recall them during the heat of the exam. Okay, because not only are you in the exam hall facing a new problem, but also there will be a pressure, because you will see your friends and your peers slogging away at their papers, and you will feel like, oh, are they solving everything and am I getting delayed? So all these thoughts will cloud your judgment, and you may not be able to recall the important formulae unless you do it so much that you get used to it. Alright, so practice these are quite fun, and these are very difficult to recall when I am not doing a problem. Otherwise I would have created a video with all of these techniques, but that that is not that organic, because we use these techniques quite personally, right? I may use a technique, my colleague may use some other technique that is known to them. So pulling it all out of our heads and then creating sums to suit these techniques, that would be cheating. Alright, so if I recall some of these when I'm solving the problems, I'll tell them to you. Alright, moving on to the next problem. So the next problem is, yeah, hexagon, right? Shortest distance between two opposite sides. Now we know that according to Euclidean geometry, the shortest distance between two points is always the perpendicular straight line. So basically this point, right? So how will we know what this height is? So let us take this to be h. Alright, we know that each interior angle of a regular hexagon is, well, I know the answer, but for you, you can calculate the value if you do not remember the exact angle. So this is n minus 2 into 180 divided by n for a regular hexagon. Alright, so n is 6 here, so 4 into 180 by 6, so cancels 30, 120, right? So each interior angle is 120 and all of the sides are equal. So if this is 120, then these two angles should be 30 each. right? And the sides are not given, so if I get the value of the side, I can calculate the value of the area. So let's take this to be S, and let's take this to be S. Apply the sine rule in this triangle that I have marked here. So you'll get h by sine 120 is equal to S by sine 30, right? So h is unknown to us. Sine 120 is the same as sine 60 because 180 minus pi. So sine 60 is root 3 by 2 and sine 30 is half. So cancel these two, root 3 gets multiplied. So h is equal to root 3 s. Alright, so what will be the side? Side will be equal to h by root 3. That means 12 by root 3. Now we got the side, centimeters. What is the area of an equilateral triangle? So for an equilateral triangle, the area is root 3 by 4 a square and s square. And hexagon is composed of 6 equilateral triangles. So for hexagon, I'll multiply it by 6. So I can use this s here. So I'll use root 3 by 4 into 12 by root 3 into 12 by root 3 into 6. So one of these root 3's cancel out. One of these cancel out, I have 3. So one of these cancel out, I have root 3. So 72 root 3. 72 root 3 is option E. Okay. So you can either remember this h is equal to root 3s. By the way, this distance is known as the apothem. Alright. So you can search up this term. It describes this distance in the hexagon. And it has a fixed formula. Even if you do not know the fixed formula, I assume that you do not know the fixed formula. So I derived it right here. Okay. Simple application of sine rule. You can do it as well. This, if you do not remember the formula, it will be one of the longer questions in the exam. Alright. It will take a bit of time. Since ESAT has you solving 27 questions in 40 minutes, we will allot approximately 1.5 minutes for each question. This is a 2.5 minute question. Alright, if you have to derive this relation. But once you do that, it becomes quite easy. You do not mess up the square roots and the calculation after you have derived everything. And do not forget this 6. Okay, so when I was trying this problem, I forgot the 6 because area is, this is the formula for area of an equilateral triangle, and hexagon is composed of 6 equilateral triangles. So do not forget to multiply it by 6, otherwise you will end up with 12 root 3. Luckily that option is not here. Okay, so if I was revising this question again for this year, I would certainly put 12 root 3 as an option. Okay, just to mess with the students. We examiners love messing with students. Okay, as soon as you get a question wrong, it feels like we got a bonus from somewhere. Okay, so all jokes aside, thank you all for joining, and I'll see you all in the next one. Bye, take care.